All right, today's lesson is about reflections. A reflection or flip is a transformation in which a figure is reflected in a line called a line of reflection. So you can see in these pictures, this bicycle is either reflected across a horizontal line or, in this case, a vertical line. It could be even a diagonal line, but we're going to try and stick to just horizontal and vertical lines for this lesson. A reflection creates a mirror image of the original figure. So let's fill in a couple of missing answers here that will help us get a better understanding of what we're talking about. So a reflection flips a figure over a line of reflection in order to create a congruent image. Each reflected point of the figure should be the same distance from the line of reflection on its opposite side. For example, in these little pictures down here, I've got the line of reflection highlighted in yellow. And if you see these little eyeballs on this smiley face, well, this eyeball is so many units above the x-axis, and on the reflection, it's the same number of units below the x-axis, which is the line of reflection in this particular case. All right, so in this case, we have an image written here in quadrant 1, or drawn here in quadrant 1. Here's the three coordinates that go with that particular triangle. Now we're going to reflect it over the y-axis, which is the axis straight up and down. So when we do that, it's going to look like this. It's going to be kind of pointing in the other way if you think of it as an arrow. And then the coordinates themselves, if you notice, you still have the same numbers, but all of the x values became their opposites because we shifted it over to quadrant 2. So how do we describe that? All the x, y values that we started with transformed in a way that we now have all negative x values with the same y value. So 2 and 6 became negative 2 and 6. 7 and 4 became negative 7 and 4. And that's what happens when we're doing a reflection across the y-axis. All right, this next one, we've got a triangle down in quadrant 4, and we're going to reflect it across the x-axis, which is the horizontal axis here. I'll go ahead and draw a little line across there. We're going to reflect it across this line, which means it's going to rotate up this way. So what does it look like when we do that? So there's the reflected triangle up there in quadrant 1, and all of these individual points, the corners, are now the same distance above the x-axis that they were below it in the initial image. So if we look at the different coordinates of each point, in the initial image we had 2 and negative 2, and now for D, now we have 2 and 2. For E we had 7 and negative 7, and now we have 7 and 7. For F we had 2 and negative 7, and now we have 2 and positive 7. So the numbers that are changing are the y values. So when you change it across, when you reflect it across the x value or x-axis, the y values are what changes because you're lifting it or lowering it to a different position. So when you put down an algebraic representation of that, you have x comma y becomes x and negative y. All right, here's another triangle. We're going to reflect this one across the y-axis and describe what happened to each of the coordinates. So when we flip it across the y-axis, there's our new coordinates. And we notice that as we did that, all of the y values stayed the same. So see how Q is still the same level as it was to begin with. All the x values have flipped to their opposites. So all the x coordinates of these points are now on the opposite side of the y-axis, and that's going to be their new value. Okay, what happens if I reflect it downward then across the x-axis? Well, when I reflect it down across the x-axis, my new coordinates In this case, the X values stayed the same as they were up here in this quadrant. What did flip though is their Y values, they became their opposite. In this case, we had 2, 2. Now we have 2, -2 for the R values. And the same thing happens for Q and P in this case. All right, Bella thinks that the transformation below represents a translation. Is she correct? Why or why not? Well, if you look at the values, you got an H here in the upper left-hand corner, but after this translation of whatever kind it is, we end up with an R prime, or excuse me, an I prime. So that means that we've actually flipped this object over. So this is not a transformation or a translation, it is a reflection. Okay, now let's use this chart below, or below here on number 6 to describe the difference in the similarities. So in these kind of transformations, the size stays the same, and so does the shape. But in a reflection, what happens is the picture is flipped, so it's oriented differently. So you're looking at the opposite side of the picture in most cases when it's reflected. So that's what happens. You're oriented differently when you have a reflection versus just a simple slide. All right, so let's take a look at this. We've got a pre-image right here. These are all the coordinates. If we reflect it across the x-axis, we mentioned a little while ago that we do that, the y value is flipped to its opposite. So we started out with 6 and 8, and now we have 6 and -8. If we start out with -5 and 1 and flip it across the x-axis, we end up with -5 and -1. So all the y values are becoming their opposite. What happens when I reflect it across the y-axis? Well, in that case, and I'm kind of comparing it with the first one, okay? So what changed on this one is the y became its, or the x value became its opposite, so 6 became -6, but the y values 8 and 8 stayed the same. So if you look all the way down through there, all of these x values became their opposites, and all of these y values stayed the same as they were in the initial pre-image. Okay, so that's what we're looking at. The assignment is reflections on the coordinate plane. I'm going to start out by filling out all of the work on our packet, and then we'll transfer the answers to Canvas so that they can be corrected. Thank you very much.